to my presentation, Vanquishing Voyeurs, Secure Ways to Authenticate Insecurely. This was originally by Zaz Kanatopic and Andre Benici. This will be presented by Adam Downs. Alright, a quick overview of my presentation. First, I'm going to go over passwords and PIN features and observation attacks. Then I'll go over quickly over observation from the outside, going over key input at insecure terminals, and machine observation and resistance solutions, followed by observation from the inside, key protection from input devices and network, and how to stop those dang logger devices, and rethinking password entry mechanics. Well, first, let's go over the need for passwords. Everybody will use one of these three items you see up here. Passwords, tokens, and biometrics are everywhere. Every time you log into, say, D2L, you're using a password. You use tokens all the time to send information across networks. Now, these things are two of them are rather common. They both can, first, with passwords, you can delegate them. They're cheap and they're invisible. Their downside is, they're easy to observe, somebody looking over your shoulder as you're typing in the password. And they take a lot of, your own physical memory to remember, depending on how long that dang password is. Tokens are another common, way to protect systems and whatnot. Again, you can delegate them, and they're cheap. You can, if you give them away, you can change them. That's fine. The problem is, they can be stolen, lost, copied, or deteriorate. Say, you have a key card somebody, gets a hold of while you're at lunch, copies it, and, they now have your key card, and you're none the wiser. Then we have biometrics, something that's been coming up more and more often to secure areas. They're easily accepted by people, and if it's your fingerprint, eye print, or the veins in your palm, there's no memory. There's no real need for you to remember anything. Again, the problem is physical properties. They can be observed, copied, or deteriorate over time. Your face may change. Your eyes can change. The veins in your hands can move. And the technology isn't quite ready yet. And there's no real way to give your finger away to somebody so they can open something for you. Alright. Another thing about this is just another weighing and measuring of passwords that was in the original presentation. All of you will recognize, probably should recognize these. Something you probably use at least once most people use once a week, if not once a day. These are ATMs. They're everywhere. They're out in the middle of street corners. They're sitting I've seen them sitting in rest stops and highway off the interstate. They're everywhere. The problem with a lot of them are they are everywhere. There's 100 different manufacturers for them, but almost every one of them is built the same way. You enter a couple of digit PIN number. You swipe your card, you enter a couple of digit PIN number, and off you go with your money. They're incredibly easy to set up observation for. There are even black market fake ATMs that will steal other people's information and basically let you clean out their account. And honestly, those black market ATMs only cost about $1,000. And usually before they're caught, people they'll pay their way relatively quickly. You can also look over somebody's shoulder and see their PIN number, and so on. This is the ATM of the future, according to Ido from Japan. Kinda looks still similar to the old one, and truthfully, I don't see the ATM changing anytime soon. The big problem is people are used to what they have now. They're used to entering their pin. They're used to putting in their card, entering their pin number, and getting their money. It's how it has been since 1958, when the first ATMs came about, and you talk to somebody over a phone to do this. Why attacking people through the physical medium or ATMs, or uh, leaving some maybe powder over a keypad at an office to see what buttons are used? It's because the bad guys know how the information is entered. It makes it easy for them to observe and break people's pins and passwords. It's that simple. Now, there are different ways other people are putting things out, including changing keypads that will randomize the numbers, or uh, follow your eye like a gaze, or follow text patterns that you can feel on the keypad. Say like this haptonic password. It's a little 3-key device that changes how each of the pads feel, and you enter your password that way. Now, this system is still in testing, but short passwords, people for the testing seem to have no problem with. It's inherently invisible to everyone except for the person touching it. And the only problem is with longer passwords. People people seem to have a problem with remembering the field, too many different kinds of fields, and the error rate starts going high from about round zero from a 3-digit to about 15% to a 9-digit, which isn't too bad considering a 4-digit password is one to a thousand that somebody can guess right. 1 in 1,000 tries can guess right. Next, I'm going to go into keyloggers and untrusted terminals. Now, keyloggers aren't just malware. They can also be things that your employer put on your work computer to make sure you're doing your job right, or husband or wife trying to make sure that their loved one is staying on the straight and narrow. Now, keyloggers can come in many different ways. They can just log in what keys you do. They could take periodic screen captures of your screen and send them on. There's also keyloggers out there that will take a quick small screenshot around where your mouse has been clicking, and take screenshots of your mouse movement to get around virtual keypads. Now, one way to try to help with this is password management, like keychains that will ways making your computer save your password, so you don't have to enter it in, or putting in a bunch of gobbledygook into a notepad and then cutting and pasting the password into a thing. Now these are kind of hard, and kind of not that. Somebody that with enough time will figure out what you did and figure out where you went and what you did. So while it makes the job a little harder, it doesn't make the job all that hard. Now, the most standard websites with passwords, like Yahoo or any web address or most other places that will require you to enter a password, they have a few things that they try to implement to keep your information safe. Not safe, safe. One is forced password changes, but that's only really a damage control mechanism to get somebody out of your whatever your password was meant to protect. Next one is an image-based access, like the image off to the side with the little picture of a couple of numbers. That's the key. That's to try to prevent bots from just constantly trying to access something. There's also changing security questions, but that one's a cognitive load problem because people can only remember a couple of security questions at best. Uh, then there's sending one-time passwords through text messages to like your smartphone or whatnot, but you have the problem of if somebody gets your smartphone and breaks it, they have access to all your passwords. Then you have those little devices like you see off to the side of the screen that when you hit a button, they give you a PIN token that you can enter. This is really popular with like gaming website games like WoW and some other actually higher security databases and such that don't trust just passwords. Now this makes the theft of a password kind of not as valuable as it used to be. But do you want to carry one of those around for each device or each website and device you want to open up? I wouldn't. Now, here's an example of one-time one-time pad scrambler, which changes will put a ring around your device and basically scramble your keys. The interface is basically a hunt and peck keyboard. You can regenerate per keystroke basis if you want. So if you hit J, it'll put in a K, but the next time you hit J, it might it'll change J to an I. Now this is susceptible to screen capture, but only if triggered by keystroke, and keystroke output encryption streams equal in length encrypted stream. It makes it harder, and really that's what you have to do. You have to make it harder for the bad guy. Well, there's also other ways to summarize this. Bad guys are going to take if bad guys get something on your screen or looks over your shoulder, they're going to they're going to get your password more than likely. So really, what you need to do is give users choices to conceal their passwords from different viruses or ways to look over their stuff. You need to if you can make multiple custom methods that are easy to implement and select. You make it. You basically think of a spy. He'll have to learn 50 different languages just to try to crack 5 people's different passwords instead of like 3 different languages. If you offer different non-traditional methods of logging in, such as audio or textile, you force the attacker to use a lot more effort to try to break in, and that's all this is really about: making it incredibly difficult, making the guy not want to try to break into your stuff. In conclusion, I've just tried to summarize the hour-long DEF CON presentation into a 10-minute thing. I had to skip over a few things, but I think I got most of their message clear. we need a bunch of different ways to just make it harder for the bad guys to break into your system, and make it just difficult and a pain in the ass, and make them not want to do it. Well, thank you.